This video is about two-variable data analysis. First of all, we will use a scatter plot. Then check the linear regression line. Is there any linear relationship between these two variables? Then we can use Pearson's product moment correlation coefficient to check the degree and the direction of the linear relationship between these two variables. Also, you can use Spearman's rank correlation coefficient to check is there any linear relationship between the rank of these two variables. You can also use a chi-square test to check whether these two variables are dependent on each other. We can also use a linear regression t-test to check the degree of linearity between two variables. In today's lesson, we will focus on linear regression line and Pearson's correlation coefficient. Let's go to example. Don took part in a project investigating wind speed, x km/h, and the time, y minutes, to fully charge a solar-powered robot. To fully charge a solar-powered robot, the investigation was carried out 6 times. The results are recorded in the table. 1a. On graph paper, draw a scatter diagram to show that the results of Don's investigation use a scale of 1 centimeter to represent 2 units on the x-axis and 1 centimeter to represent 5 units on the y-axis. This is an IB graphing paper. We know from here to here, this is 1 centimeter with 5 small units in it. Do not forget to label x, y axis with the units and also the origin. 1 centimeter to represent 2 units. So this is a 2, 4, 6, 8. Keep going. I labeled to 30 because the maximum value for x is 30. 1 centimeter to represent 5 units. So this is a 5, 10. Keep going. Then you can plot the points. You have 6, 28. We know 1 small unit on the y-axis stands for 1 minute. For x-axis, 1 small unit stands for 2/5, 0.4 km/h. So 6, 28. This is a 25, 26, 27, 28 is here. We finish plotting these coordinates on this graphing paper. For 1b, calculate x, the mean wind speed. First of all, we will press Stat, Edit. Then we will put x in L1 and y in L2. Then go back to Stat, Calculate. This time it's a 2 variable stats. Go to 2, enter. no frequency list. Then you can get X bar, that's the mean for the wind speed. Keep going down, you will get Y bar for the time. So we see that X equals 19. For 1C, calculate Y, the mean time to fully charge the robot. Y equals 32. M is the point with the coordinates x, y. Coordinates for M is 19, 32. Plot and label the point M on your scatter diagram. 19 is in the middle here. Keep going up. 32. This is the M, 19, 32. For 1E, write down the equation of a regression line y on x in the form of y equals mx plus c. Interpret the meaning of m and c. First of all, let's go to mode to make stat diagnostic on. Press mode, then going down to stat diagnostic is here. Make it on so that we can get Pearson's correlation coefficient. Back to stat, calculate, go to 4. We just press 4 here. Then keep going down, enter. You will get a linear function here. The slope of a linear function is 0.465. The y-intercept is 23.2 at the 3 sigma fix. This is Pearson's correlation coefficient, 0.944. We already got the equation of a linear regression line. Y equals 0.465x plus 23.2. We need to interpret the meaning of M and C. From this linear function, we know slope is 0.465 and y-intercept is 23.2. For slope equals rise over run. Here, rise is time. Run is wind speed. We will make 0.465 as a fraction over 1. Then equals time to over wind speed. The units for time in this question is minutes. The units for wind speed is kilometer per hour. Slope is 0.465 over 1 means that when wind speed increases by 1 kilometer per hour, the time to fully charge the robot will increase by 0.465 minutes. For y-intercept, units will be 23.2 minutes. Y-intercept will be initial value. When x equals 0, y equals c. In this question, x equals 0 means that the wind speed is 0. In other words, without wind, the time to fully charge a robot is 23.2 minutes. Let's go to 1F. Draw this regression line on your scatter diagram. The regression line must pass through mean point and y-intercept. This is the rule when you draw any regression line on the graph. So you have to pass through this mean point here. And also the y-intercept is 23.2. 23.2 is here. This is the y-intercept, 23.2. Then you will use a ruler to connect these 2 points. This is a linear regression line, y equals 0.465x plus 23.2. Pass through this y-intercept and also the mean point. For 1G, hence otherwise estimate the charging time when the wind speed is 27 km per hour. We will use this regression line equation to estimate the charging time. So for 1G, we will get y equals 0.465 times 27 plus 23.2 equals 35.8 minutes. Remember, for word problem, do not forget the unit.